Hello, welcome to the latest episode of Data Unchained. I'm your host, Molly Presley. If you haven't heard our podcast before or need a little refresher, let me tell you a little bit about what Data Unchained is all about. Over the last couple of decades, the access methods, where data has been created, and how people want to use data has changed dramatically. We've had the advent of cloud computing, which moved workloads out of the data center into the cloud. There's been a massive movement towards data being generated at the edge. And now in the world of AI, folks are wanting to use all of this data to drive insights, make decisions, become more efficient, and technologies are needed to help customers meet these goals. Data Unchained delves into both the problems as well as the solutions in this distributed data world. We haven't had David Flynn on for a while. David, thank you for joining.
Hi, Molly. I'm glad to be here.
David is the founder and CEO of Hammerspace and previous founder and CEO of Fusion.io. So, David, you've been part of the problem of decentralized data as well as the solution of how we're bringing it together in your various ventures in technology. Great to have you on. So today's a big day at Hammerspace. You've announced a pretty massive new category of product architectures. Can you tell us a little bit about what led to the decision to really found a new category of NAS technologies?
Originally, we had single system NAS or scale up NAS and then scale out NAS, but these have had limits in their scalability. You can scale capacity very well, but frankly, they don't scale performance beyond maybe a couple of dozen nodes. So we felt that in the modern era, we needed to make file-based storage, or NAS, much, much more scalable. As we saw in the introduction of cloud and object-based storage, kind of an admission that file storage isn't able to go to the cloud scale that's needed, that you would introduce a dumbed-down file system, S3 or super simple storage, to try to get the ability to scale unstructured data. But that is a cop-out. You're giving up all the benefits of having a real file system. So I think the industry's been in need of better scalability in file storage for quite a while now.
And when you talk about scalability, are you talking about more petabytes of data in a single file system, or does it go beyond that?
It goes beyond that. Scaling capacity is relatively easy. What we're talking about here is scaling performance, and not just bandwidth and IOPS, but having very low latency as well. These are very difficult things to scale. And typically, scale out NAS architectures maybe can scale to a dozen or 24 nodes before additional nodes don't really buy you any additional performance.
Both you and I have worked in the supercomputing space and various components of that technology for decades. Why not just lean on parallel file systems and Lusters and GPFSs out there?
Well, the fact that those exist and have any footprint at all is kind of an admission of the failure of the traditional NAS industry to address sufficient performance and scalability. We have these, I call them exotic file systems like Luster or IBM GPFS. Now I guess they call it Spectrum Scale, or even StoreNext, or if you want something even less mature and more recent, something like Weka. The reason why these file systems exist is because the traditional NAS protocols they don't allow you to have true linear performance scalability, and they get used in places where application performance is paramount. In the HPC environment, you don't want those systems sitting idle waiting for data. And so it's kind of the trade-off: spend engineering time and effort to deploy and manage these exotic file systems so as to save application runtime and get better utilization of the hardware. But there's really those two different worlds, the exotic parallel file system world of the supercomputer and traditional NAS and scale out NAS world. And, never the twain shall meet. There's never been something that really brings together the performance of one and the convenience and feature set, standards based nature of NAS.
So never the twain shall meet until today, I think is fair to
Until
say.
today.
So
Until
tell us
today.
a little bit about how is Hyperscale NAS bringing those two technologies together. Tell us a little bit about the architecture.
So Hyperscale NAS actually takes the architecture of the parallel file system from the supercomputing world and brings that into a standards-based NFS world. So what has really made creating Hyperscale NAS possible is the fact that Linux won the OS wars, and in the data center, it's the only OS that matters from a performance and scalability perspective. Now, why does that matter here? Because to build these high performance supercomputer class parallel file system, it requires a much more intelligent client. The client stack and that's the Achilles heel of those exotic file systems. You have to install that client and you have to maintain it. It goes deep down in the kernel, and so it can compromise the supportability of your kernel and so forth. But you need a more intelligent client to offload the data routing task. And Linux, now having won the OS wars, means that we can make that investment. So the reason why is it now possible is because Linux is the only client that really matters. Yes, as NAS, we need to support not just legacy NFS as well as this high performance parallel, but we also need to support SMB and the entire feature set and rich world of enterprise NAS, which we do, which Hyperscale NAS does. But we want to bring this more intelligent client in. And this is where Hammerspace specifically has been able to do this, thanks to our CTO being the author of the client in Linux. He's the kernel maintainer of the NFS client and has been for the past 20 years. So that code is mostly his at this point. And that's allowed us to enhance the client and the standard so that regular NFS off the shelf built into Linux is capable of this much more sophisticated functioning. And what that functioning allows us to do basically is eliminate a whole entire layer of gateway nodes. Scale out NAS, you have gateway nodes that redistribute the data across the storage nodes. So those front end protocol nodes and the back end storage nodes. In Isilon, they were early in using InfiniBand to try to get that internal network between the front end nodes and the back end nodes to be fast enough. And with more modern incarnation like VAST, they're using NVMe over Fabrics. And the Fabric, again, it's like an InfiniBand thing there. But that really belies the fact that you have to have two layers. You have front end nodes and back end nodes. And the reason you have to do that is because you don't have a sophisticated enough client. With parallel NFS, with Hyperscale NAS, the client can route the data directly to the back end storage. You don't need that intermediary layer, which gets rid of 2/3 of the networking that's necessary because you don't have to have a bump in the wire with the gateway nodes. So it's a radical difference in performance and scalability, a radical difference in the cost structure, especially if you're going software defined. You don't want to have two layers of boxes and the networking in and out to go through the middle there.
So I know that Hammerspace announced a variety of customers today that are using this technology for their storage environment as part of the Hammerspace global data environment. I think the name can make it imply as though this is only for the very large, but I think it's worth emphasizing customers with just a few nodes all the way up to very massive environments will get the benefits of Hyperscale NAS because the architecture is designed, like you said, linearly scalable. Whether you want to save money and be fast and have enterprise data services for your 100 terabytes or your 100 petabytes, this is super relevant to you. Would you say that's a fair statement?
Yeah, hyperscalability also means it can scale down to just a few nodes and be much more efficient with delivering that performance, um, and scale up to the hundreds of nodes. So it's the dynamic range that matters. And with a hyperscale NAS architecture, it's actually more cost efficient at both the scale down and the scale up side of the spectrum, because you don't need that intermediary layer. It makes it, if I'm just a couple of nodes, at least now they're adding performance instead of just being a bump in the wire.
I know that this architecture was proven out at pretty massive scale with one of Hammerspace's customers, which we're not allowed to use their name externally, but a hyperscaler that's been using it now for, gosh, almost a year as they've been doing development and going into production. Can you tell us a little bit about that environment and what kind of results they're achieving?
Well, what's interesting here is you have a company that comes from the web scale heritage, where they'll spend any amount of engineering time to reduce cost, and they have very large homogeneous applications. So they typically build their own object store or blob store and customize the applications to use that. But with AI workloads, you need a more general purpose file system for home directories and holding massive data sets, and for the very um, diverse workflows that you have with AI. So they found themselves needing to have a true feature rich file system to perform a lot of this AI work, and with the ability for that file system to feed data in parallel. So that's where Hammerspace and Hyperscale NAS came in. And the beauty of this is it helped us to prove out at scale what hyperscale NAS can do. And in their case, they have clusters at 600 nodes, even 800 nodes. They expect to go to over 1,000 nodes. Those are the storage nodes, each one of those with 100 gigabit Ethernet. In the future, those are going to be 200 gigabit Ethernet. But even as it stands now, you're talking about uh, multiple clusters at 800 nodes. It's 80 terabits per second. I mean, some of the RFPs for supercomputers going in at Los Alamos or Lawrence Berkeley National Labs call for an IO subsystem that can maybe do, 10 to 20 terabytes per second, or 80 to 160 terabits per second. And we're already pushing that scale here, and growing. So this really can rival the hero class supercomputer file systems like you might see with, say, a Lustre or a GPFS. But in this case, it's standards based and built into Linux.
So let's just kind of run down a few of the benefits for folks who are listening. And probably everyone who listens to the show is running a NAS in their environment. Probably a few different types of NAS would be my guess.
Mm-hmm.
So let's talk about performance a little bit. You mentioned Los Alamos National Labs, and you did a webinar with Gary Greider a few months ago where there was a neat little comparison about the number of file systems that they have at Los Alamos to meet their different needs. How does Hyperscale NAS simplify the number of file systems while delivering the types of performance they need on mixed I/O, throughput, metadata, et cetera?
Well, almost all of these organizations have NAS, but they also have to have these exotic file systems, and they have workflows where they have to copy the stuff from the one into the other so they can feed it into the HPC cluster. So by having a NAS environment that is performant enough to directly feed the cluster, it greatly simplifies those workflows. And the cost structure of the entire thing. So, there's huge benefit in being able to deliver the data at scale and at performance directly from your enterprise, feature rich, highly reliable NAS environment. Because NAS is kind of what everybody has to have, because that's what we trust to protect our data over the long term. But they have to bolt on front of it something to amplify the performance and copy data into it. And that's this Lustre or GPFS or one of these exotic file systems where data is really only trusted to temporarily hold the data while you're feeding it. So we get rid of that whole thing. I liked how Gary Greider put it, as it's many file systems in one. I like to think of it as just building a file system that's capable of the full gambit, and then you don't need to have these others. And as we saw with our recent announcement on tape, being able to embrace the very deep capacity into the spectrum from within the same file system is actually very powerful as well, because it's about that dynamic range.
Makes sense. And I know that you're announcing as part of this today's announcement that you've been certified with the NVIDIA GPU Direct. How important is that to the Hyperscale NAS architecture?
It's incredibly important to be able to use RDMA and direct data paths. It's all about reducing the number of times data has to be retransmitted. GPU Direct is about getting it off the wire into the GPU without having to go through the root processor complex and memory. You don't have to put it into memory just to take it out, to put it in the GPU's memory. Hyperscale NAS similarly avoids the data having to be copied through a front-end node, a protocol node that you would see in a scale-out NAS architecture. So the fact that you even have things like NVMe over Fabrics, or that you used InfiniBand inside of the Isilon, those are admissions that you have this data retransmission problem. In our world, you don't have that, and the data can go directly from the storage node to the client in one hop. And from the client, get into the GPU using GPU Direct. So it really does eliminate a lot of the networking. It eliminates 2/3 of the number of network ports that you need to deliver a certain bandwidth of data. I mean, the cost difference between hyperscale NAS and scale out NAS is dramatic, just because of the amount of hardware gear that you get rid of, because we've made a more intelligent client.
So the efficiency comes from, like you said, a reduction in the amount of networking ports and infrastructure you need, the number of nodes that you, or the amount of hardware you have, because you're eliminating a lot of the storage infrastructure. Yes. Let's talk a little bit about the efficiency also on the IT side. So you collapse a bunch of file systems into one. How does this all work? So you're saying it's just one file system to rule them all. How does that help IT?
Well, the beauty is it's just NFS, so it comes built in. So while I talk about a more intelligent client, it's also been in Linux since RHEL 7. So we laid the groundwork for this many years ago by pushing the standard and the implementation upstream into Linux. So from an IT perspective, this is like NAS, about as plug and play as you can get. It'll work on standard Ethernet networks. Yes, it can also work on RDMA capable networks and fabrics. That's true. But it's plug and play. It's got the rich feature set that you would expect from the NAS environment, like your snapshots and your clones, the other data services that help users avoid, accidents and damaging their data. So a very powerful set of features for it. And what all of this boils down to: ease of use, reduced amount of administrator overhead. Um, Managing a GPFS or a Lustre environment or a WEC environment, you got to hire engineers for it.
Yeah, absolutely. So, David, when you think about enterprise NAS, I think what that means for most IT teams is a very locked down and hardened environment related to security, data protection policies, ransomware. How will IT teams accomplish that with Hyperscale NAS? Have you built all of that into the technology as well?
That's right. All of the audit capabilities, all of the antivirus capabilities, your convenience to snapshots and clones, things that help protect against even a user's own mistakes. The way I like to think of it is, in the enterprise world, reducing risk is paramount. And risk of data loss, of data theft, risk of somebody damaging their own data sets, these types of things. Enterprise NAS is all about reducing risk, whereas the world of HPC file systems was all about reducing runtime, reducing how long it takes to feed the data in and to get the data out. And that is so important that they would sacrifice other reliability. That's why data resilience and such is, typically not that great. The reliability of those file systems is not that great, but the performance is stellar. So the beauty of hyperscale NAS is you have the risk reduction of enterprise NAS, and you have the performance of the HPC exotic file system world all rolled into one.
So I know a big messaging point is enterprise standard throughout all of this, and that's data services. It's using existing, already approved Linux clients with the version of Linux that's already running on it, enterprise standard hardware, Ethernet, InfiniBand. But can you talk a little bit about how you support other storage technologies as part of this? So it's not just white box, but also it could run in front of an Isilon as well.
Well, and that's the benefit of this being part of Hammerspace and data orchestration, is that for Hammerspace, any traditional NAS is just another storage node in the parallel NAS, in the hyperscale NAS environment. So you can incorporate your existing NetApp gear, your existing Isilon gear, even third-party NAS systems, open source or other. Those are just storage nodes, and that indicates why you can just take Linux off the shelf and turn on its NFS server, and it's a storage node. So that was one of the things that our web scale partner found very compelling, is that they could use their own Linux, both the Linux as the client, but as the storage nodes as well. And that even opens the opportunity for their compute nodes, the nodes that hold the GPUs, to also participate as storage nodes in the storage cluster. Think of it as a hyper-converged model to where the GPU servers hold storage space, and they are all sharing that to create a reliable storage fabric underneath the jobs that are running. So Hyperscale NAS also allows for a hyper-converged architecture, because anything that speaks NFS is a storage node. Your compute nodes can actually be storage nodes too.
Okay, so you've done a great job of not using the word AI yet, which is unusual. But I do want to talk about that for a minute. This web scale customer you're talking about is using us for AI. Can you talk just a little bit about the use case?
Well, that's right. It was AI that kind of was the straw that broke the camel's back, that forced them to need to use a real file system. You couldn't use object storage or their own custom blob store, because the workflows are too diverse, and you need a general purpose IO subsystem. You need to be able to do POSIX IO. So that's both for data ingest into the cluster, and these are potentially months-long training jobs that incorporate thousands to even tens of thousands of GPUs running for months at a time. You need to be able to do checkpoints, because you're going to have hardware failures, and you need to be able to roll back. Or you need to be able to roll back so you can try changing the data you train on if you realize that there are reasons to need to steer the training in another direction. You can go back in time and replay it. So all of this requires a data platform that can do a very diverse set of workloads with high performance, reading and writing, very large file bandwidth, as well as small file kind of stuff. One of the defining features of the AI world is that you have to have a very well-rounded set of performance, unlike HPC, where it could be highly tuned to the specific kind of jobs you are running for, say, just bandwidth or just checkpointing or whatnot.
So using Hyperscale NAS to serve data to AI models, large language model training, that's awesome. There's also an evolving market of using AI and machine learning within products to make IT's job more efficient. Can you talk a little bit about how you use machine learning and use that built to automate some of the data services as well?
We use AI internally to make the decisions about where to place data and when to move it across the various different storage nodes. So it's really kind of interesting that Hyperscale NAS can form the foundation for these models, for these foundation models for training. And it internally is using AI to predictively place and move data sets to where they're going to be needed so that you can operate on them fast enough. And this is what allows us to incorporate things all the way back to tape, uh, disks, and flash, and hyper-converged flash in the GPU servers. That's a very, very wide range of performance and locality of the data, and being able to move the data up and down that hierarchy of latency needs to be able to be done predictively. And this is where service level objectives and objective based data orchestration come in. And at the heart of that is using a machine learning technique to make the decisions about placement and movement of data.
So this is a huge advancement in the storage industry, the data pipeline industry, using a lot of really interesting modern technologies, as well as building it into Linux, which has been, like you mentioned, something Tron's been working on, our CTO, for a couple of decades now. But I think the benefit is pretty massive and pretty obvious that in today's world where AI is being commonplace and people want to use their data, not just store it, they need to power these GPU farms. Hyperscale NAS is a pretty urgent technology to get into the market.
Well, it's interesting that we're using AI to solve one of the biggest challenges with running AI workloads, and that's the management and the feeding of the data set. And that allows us to accelerate the cycle for it. And at the heart of all of this is the ability to put data movement behind the file system by having a file system that is simultaneously capable of these extreme levels of very diverse performance, but also capable of orchestration and moving data behind the scenes without interrupting the view of the data. So hyperscale NAS and data orchestration allow us to bring to bear this intelligence about the movement and placement of data, which is really to say that for the first time, we can automate some of the most manual, error-prone, time-consuming tasks that existed in the world of enterprise IT, and that's the movement of data. We get rid of data migration. There is no such thing as data migration. There's no downtime. Data can simply move from one piece of infrastructure to another while you're still using it. So it's funny, data is the very definition of digital, and yet it has been desperately crying out for digital automation, how we manage our data. And for the first time with hyperscale NAS and data orchestration, we can automate the data janitorial work because it no longer interrupts the access, the ongoing consumption of data to be moving it across different systems. And then add on top of that the global file system capability, the ability to have that same file system presented in multiple data centers. And now you really have the magic sauce for making AI workloads. You can feed data at the performance levels they need. You can move data up and down the cost, capacity, cost, performance spectrum. And you can do that in different data centers simultaneously so that you can tap into GPU resources and other compute resources in different places.
So this sounds like this kind of technology that's going to appeal to a lot of different verticals and markets and use cases. Are there any specific ones where you suspect that there will be the most adoption? Is this going to be in HPC or financial services, or do you expect it's just going to be across the Fortune 500 in general?
It's bringing together these two worlds. There's been a lot of industries that have used scale out NAS and made do even with the lower performance. And so whether that's the media and entertainment world or, bio and life sciences world or the chip design world or, the energy exploration, industrial design, most of them have chosen, when they had to pick their poison, they fell on the side of, I'd rather have the risk reduction of enterprise NAS versus the super high performance of these exotic file systems. But they no longer have that luxury of staying safely on their side of that void. With AI, we need to increase the performance levels even more. And with the business cycle and competitiveness, even to stay competitive there, even for those traditional workloads, not just the AI workloads, they need higher performing, more scalable file environments. So I think we're going to see all of the traditional consumers of NAS and scale out NAS who have been needing more performance. Those are going to be very big industries. And then you have the HPC world where they all of a sudden need to have a more general purpose file system and one that can better manage risk than these exotic parallel file systems. So they too are having to move outside of their traditional world of custom exotic file systems and go to something that's standards based and can help them reduce the risk of working with data that could be highly sensitive personal data like we might be using for training AI models, and move to file systems that can handle a broader range of performance than a specifically tuned parallel file system.
Well, David, congratulations on bringing such an innovative new technology into the market. I know it's been a lot of time and blood, sweat, energy, money, et cetera. But I know even with all the success you've already seen with the technology, it's going to be game-changing for the markets. And thank you for taking time today. I'm sure you've been quite busy, and it's a big announcement for Hammerspace.
Well, it's my pleasure to be here. Thank you for having me on.
Absolutely. And anyone who wants to learn more, go to the hammerspace.com website, and you'll be able to find a lot of information about customers, technology, analyst takes, performance benchmarks, et cetera. So whatever it is you're looking for, jump over to the hammerspace.com website, and I'm sure you'll find it there. Thank you for joining, and thanks for being here, David.
Thanks.
Thanks for listening to Data Unchained, powered by Hammerspace. To learn more, visit hammerspace.com. If you have a guest you would like to hear on the show, email me at molly@hammerspace.com.